Okay, thanks everyone for checking out our video. What we're going to do here is try to walk you through what we did with our project, and what we did is use Kangaroo to create a form based on gravity, or like a funicular form, and use the Grasshopper script to come up with several different iterations based on Kangaroo and gravity. And then the workflow then is to take it from Rhino and the Grasshopper script and put it into Revit, where we then can create our deliverables. So I'm going to kind of walk you through this a little bit here, how this works. What I've done is just basically open up Rhino, and we're going to create some form here. Got some lines, and just got another curve, and so what we're going to do is we're going to sweep this curve. We're going to do a sweep 2, sweep this curve along these rails just to get our basic form. And so now once we have our surface shape, this is our form that we're going to use with Kangaroo. So we're going to open up our Grasshopper script here, and you can see what we've done is we've got a mesh here, and we've used Weaverbird to then convert this surface and use the Kangaroo script, which is basically a set of springs based on gravity, to create our form. So what we're going to do here is in this mesh tab, we're going to set one B-rep to the surface, and then you can see the Kangaroo takes over based on the script that we've written and begins to wildly change this form all over the place. And it's kind of cool. It's kind of fun to watch this thing just fly all over the place. And this is all basically based on gravity from the Kangaroo plugin, which is pretty fun to use, and we had a good time with it. But anyways, how this works is this toggle right here turns on and off the spring setting, and the slider right here basically sets the strength and the direction of gravity, so you can move it to negative and it'll go downward, and you can come back over here and retoggle. If I can get it to go here real quick, retoggle this, and then resets the spring, and gravity takes over. And now that we have it slidden down to negative on the slider, it's going to be pulling the form down, and we can play around with this a little bit too and move it back up. And now gravity takes over literally in the other direction. So that slider right there controls the strength and the direction. And so what this does then is takes us all the way through to create a mesh. And so what we're going to do is we're going to bake out this form right here to create a mesh, and here's basically one iteration. So we're just going to move that off to the side, and so what we've gotten here is a mesh, one of our iterations. So we can go back in, and to get another iteration, we're going to change this slider again. We're going to let the gravity go in the other direction. We're going to create a hanging form this time instead, and so we go back over here to the mesh, bake this out, and it's quite interesting the way this thing bakes out, and you can bake it out in different segments, different times, so that flexing is sort of happening at different periods. But anyway, so we'll pull this mesh out, and there's our another iteration for us, and yeah, have a lot of fun just playing around with these forms and getting your different iterations. So what we're going to go do is now is open up our second Grasshopper script, and this really takes our so what this second script does is takes our meshes and divides them up into, we really had to kind of create a surface back out of this mesh. We had sort of a hard time figuring out how to turn a mesh back into a surface, and after we sort of created this, I think there are some easier ways to do this, but this is one way how we solved this problem, was to basically divide up this mesh into basically a UV grid again, and then assign points off those divisions, which we then take back into Revit. So really that's what this part of the script is doing, is we're rebuilding this mesh, number of sequential points, number of step points, which is basically just the dividing up of the mesh. And then as we move a little bit further into the script, you can see here we've got a slider for the number of U division and the V division, and then we've got a distance slider here which offsets the surfaces, because what we're doing is we're taking two surfaces or two corresponding sets of surfaces with points defined back into Revit, and having our adaptive components adhere to the set of points that correspond to both surfaces. So that's what this slider does, is it's adjusting the distance between the two offset surfaces. So basically this controls your panel thickness based on your adaptive component in Revit. So that's kind of interesting little slider right there, is we can create thicker or thinner panels or shell forms based on that slider. And so what we've done then is taken all the points that come out of these, and let me go back just a little bit, indexed them all to group them so that Revit knows what to do with them. We plug these into the vertices, which then go to our Revit communication. That's the push over to Revit. We've also created adaptive points here. You can see this point here in space, and we've got another point, if I can get to it here just a little bit further over here, and these are going to be used as the parameters to control different functioning in the panels themselves. And so what we've got now is the control, which pushes us into Revit, a little toggle right here, and when you toggle that, it wants to send the information over to Revit, which we then come over to Revit and go to our Chameleon add-on and place Grasshopper, place adaptive, and you can see here we're going to select the type of adaptive component. We're going to select what the parameters do, and in this case one's going to just basically do nothing, and the other one's going to control the frame. And then you can see it here as it's coming into Revit, it's rebuilding the surface, and sort of fast forwarded there a little bit. But what we've got here now, if I can go back again just a little bit, is we've got our surface that we've defined in Rhino and then brought into Revit, and had Revit rebuild the surface with these adaptive panels. So I really think it's a great workflow, because Revit is so much better, or at least the way I know it is pretty good at producing our deliverables, and then we can start to look at these different lighting qualities based on these panels with the different views, and all the great things that you can do with Revit. So as you can see there, it just basically comes in as the geometry. So what we've done here is just basically build a quick adaptive panel to adhere to those points, and this is just really a quick and dirty, this one's an 8-point adaptive with a oculus in the middle, but as you can see we're flexing this thing all around, and it's totally adaptive, and all of these numbered points are going to adapt to the numbered points that come in from Rhino. And again, this is just a different type of panel that we created. This one's got this same type of setup, all the different points, all the different adaptive points, only this one has a glass inset into it with a sort of shading device hanging off of it, and you can see we can flex this around, and the panel then changes shape and form so that wherever those points are as they come in from Rhino, this panel can just adhere to it and basically just snap into place and create the form. So that's the beauty, I think, with this workflow is, we can build any type of panel we want here, load it into our project. In this case, we overwrite the existing. And then what we can do is when we bring in a different panel type, we can actually go back and just get rid of all of this geometry with the first panel type. Just delete it and get it out of there, and actually take us back into Revit, reactivate the control, send the form back in from Rhino, go back and place our adaptive component, change the component. This time the component is the shade component, shade component, and then it'll rebuild the surface with this new component, and we'll see a different type of geometry. Now this is just the plain, this wasn't the panel I was just building or just showing, but it is just this is just a plain component with no oculus or anything like that. But you can see how iterations become really quick in this workflow, and we built that geometry, and now we can just repopulate it with different panels by moving back and forth between the Rhino and Grasshopper script and into Revit. And so then from there we can see how these lighting qualities change, and you know, we can also do our plan views, our elevation views, our 3D views, you know, all within that new geometry with each new panel. And so we can actually just get rid of this again, go back in, retransmit our geometry from Rhino and Grasshopper back into Revit, and again go to our Chameleon add-on, place our adaptive component. We can change to a different style of panel now. We can change to this type of panel and then use the parameters to then drive different functionality within the panel. And now we're going to you know, just basically sort of showing how all that information comes in and then gets rebuilt here in Revit. And now this time we've used the panel with the glass in it and the interior shading devices to then, you know, give us a whole different quality based on the same funicular form, which is generated from gravity. So I think this has been pretty successful in experimenting with this workflow, and I hope you take advantage of the files that we put up and play around with them and see where else you can push this. But we were pretty excited as far as how this workflow went and how we could easily, you know, work with this parallel workflow and developing the panels in Revit and the geometry in Rhino and combining them into one. So thanks for watching.